first thing is let's kind of remind ourselves how we can prove triangles are congruent. So it might be helpful for you to have your day one notes out for this. But who remembers what are some ways to prove triangles are congruent? We learned some theorems. Anyone remember what one of those is? They're like the little abbreviated shortcuts that we did on Thursday. Yep, that's one of them. Good. So side, angle, side. Good. Can somebody else tell me another one? Yeah, hypotenuse leg. That's exactly one of them. Who can give me another one? Side, side, side. Good. Another one? What was that? I'm sorry. Yeah, angle, angle, side, and then the last one. Yeah, good. Angle, side, angle. Those are the 5 ways to prove triangles are congruent. So if you see a proof and it says, prove this triangle is congruent to this triangle, one of these is going to be your last step. You're just going to have to figure out which one it is, which one makes sense given the information. Something that people occasionally try to use is they think, oh, well, angles, right? We have side, side, side. Why can't we have angle, angle, angle? Does anyone know or think they have an idea why there might not be an angle, angle, angle congruence theorem? Why would the 3 sets of angles being congruent not be enough to show that 2 triangles are congruent? Or could someone give me an example of why that wouldn't work? Yeah, a perfect example of this is, think like, I know it's not a triangle, but think about like a square. In a square, couldn't you have a teeny, teeny, tiny square where all the angles are right angles? And then couldn't you have a giant square where all the angles are right angles? So in that case, those 2 shapes wouldn't be congruent, but they have the same angle measurements. The same thing can happen with triangles. A kind of an easy one to think about is an equilateral, equiangular triangle. That's where all the sides and all the angles are the same. Well, I guess let's not mark the sides congruent. That defeats the purpose of what we're doing. But let's say you had an equilateral, equiangular triangle where all the angles are 60 degrees, right? So all the angles here are 60. Well, couldn't you also have an equilateral, equiangular that's much larger? Or an equiangular where all the angles are still 60? Are these 2 triangles congruent? No. But do they have 3 sets of congruent angles? Yeah. So you have to have something else because the angle size actually stays consistent no matter what the shape is, so, or no matter what the size is. So what we're going to say is that two triangles can be different sizes but still have congruent angles. Okay, so 2 triangles can be different sizes but still have congruent angles. So we're just going to practice applying this some more. We want to remember some of that vocab. Oh, I forgot to. I said I was going to add that vocab sheet, and I totally forgot about that. Give me 1 second, and I'll put that up so you guys can grab that real quick. think I have it on here. Yep. Okay. So in today's module, real quick, I am going to put our old vocab sheet in it. So if you do not have that, in a minute you'll be able to go to today's note page, the 5-3 day 2, and download that. That will be very helpful to you. Was anyone able to find their vocab sheet? Okay. It'll be super helpful so that you guys aren't guessing about what things mean. Okay. Okay. If you go to the 5.3 day 2 notes in your module for today, I just linked in the vocab sheet. It says click here for the chapter 1 and 2 vocab sheet. It's in blue text, highlighted in yellow. I highly recommend that you have that handy for this. It'll be very helpful to you. All right, so onward then. In this situation, we are given that segment BC is congruent to segment DA, and that segment BC is parallel to segment AD. We are going to prove that triangle ABC is congruent to triangle CDA. So the first thing I would do is put in your freebies and then figure out what information we have about this picture before you complete the proof. So our freebies are our given. We are given that segment BC is congruent to segment DA, and that segment BC, it's being glitchy there. So, and that segment BC is parallel to segment AD. So that is our given. We are going to prove that triangle ABC is congruent to triangle CDA. So that means this last reason here has to be one of these theorems: side, angle, side, hypotenuse, leg, side, 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 angle, side, or angle, side, angle. Let's take a look at our picture and see which one might make sense. Are we already given anything that's congruent in our picture? Or not in our picture, but in our given? Yep, we are given that segment BC is congruent to segment DA. So it's giving us a freebie set of sides. So there's one S. Then it's telling us, see these little triangles here? And here it says it's parallel, right? So the top and the bottom of this shape are parallel. We talked about this last class. Let's see if anybody remembers. Does anyone remember why you would maybe be given parallel lines? What's that going to have you look for? Yeah, very good. When you have your parallel lines, you're probably going to have your Z shape. Alternate interior angles. Connect from your one parallel symbol to the other. So from the top parallel symbol, and then you're going to have to go across, and then to your other parallel symbol, and there's your Z shape. That means that these angles in the corners here are going to be congruent. So there's a set of congruent angles. So we've used both parts of our given now. We were given a set of congruent sides. Parallel lines are always going to give us congruent angles. I would maybe make a note of that. Parallel lines give us congruent angles. Parallel lines give us congruent angles. I'm sure there's at least one or two on your homework with parallel lines. All right, good. So now we've kind of used up our given. Once you use up your given, you got to look at your picture. When we look at our picture, we want to look for things like vertical angles, our bow tie shape, and shared sides. It's when our two triangles are connected along one side. So is there anything your picture is telling you in this problem? Anyone see something we talked about last class? Yeah, absolutely. AC is definitely a shared side. Those two triangles are connected along it. So this is a shared side here. So shared side. And remember, the shared side is always congruent to itself. So there is another S. So now take a look. We have two sets of congruent sides and a set of congruent angles. So take a look at our possibilities. Which theorem do you think this is? Side, angle, side, hypotenuse, leg, side, 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 angle, or angle, side? Very good. Side, angle, side. The angle's in the right place. It's where the two sides connect, right? And if you go around your picture, it says side to an angle to another side. So now really all we have to do is just fill that information in. We already have our one set of congruent sides. The next thing we did was look at our parallel lines, which gave us our congruent angles. Now something, I think I did this on your homework, and I mentioned this last time. Anytime you have angles in a picture, if you don't want to have to use all the letters to name them, because sometimes that can get a little tricky, you can always rename them with numbers. So I'm going to call this top right corner one. This is angle 1. And then this one is going to be angle 2. So angle 1 and 2. And that just makes it a little bit easier to talk about it in your proof. So you're not stressing about like, oh, well, what letters do I put? What order do I put them in? So we're going to say that angle 1 is congruent to 2. And does someone besides L, because L told us originally, does someone remember what angle relationship that is when we have our Z shape? Yeah, good, Gannon. These are alternate interior angles. So we say the alternate interior angle theorem. And you can abbreviate that. I'm just writing it out so we remember. That's the alternate interior angle theorem. Good. Then we have our shared side. That's AC. Does anyone remember from last class how we talk about our shared side in our proof? How do we write that statement? Yeah, very good, Colin. We use our reflexive property. We say it's congruent to itself. So you could say segment AC is congruent to segment AC, or CA is congruent to CA. The order there doesn't matter. Do it whatever way you like. And yeah, Colin said that would be the reflexive property. Good. And now we are actually done, and we agreed that this was the side angle side theorem. So that is going to be our final step. Sounding familiar? Hopefully some of this is coming back to us from Thursday. But again, we're just going to be practicing this and seeing, how it looks in some different scenarios. Any questions about the first one? Okay. All right, number 2. Number 2, we have that segment MN is congruent to CN and that segment MC bisects DL. We want to prove the triangle D or CDN is congruent to MLN. So let's fill in our freebies first. segment MN is congruent to segment CN, and segment MC bisects segment DL. That is given, and we want to prove that triangle CDN is congruent to triangle MLN. And remember, our last step is always one of those theorems. So we have to decide which one works. Side, 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 angle, side, hypotenuse, leg, angle, side, angle, 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 side. So let's look at our picture. What freebies are we given? What do we already know that we don't have to worry about? Yeah, we are given the freebie of 2 congruent sides. So we have a set of sides there. Good. Then that's really the only thing that's marked. I know this is marked as a right angle. We'll get to that one in a second because that has to do with our picture. So that was really our only given freebie of things that are congruent. But now we have vocab. We have the word bisects. We used this vocab word last class. So if you need to, go back and look at your notes. Who can remind us if one line, so if MC bisects another line, DL, who remembers what happens? Or go back and look at your notes. We did it, I think it was on the back of the notes. Okay, we will have 2 congruent segments. There's one little thing we have to say before that, though. Right, exactly, yeah. But segment bisectors are a little tricky. So remember, with a segment bisector, we have like a little extra step in there. The bisector gives us a midpoint, and then the midpoint will give us the congruent segments. So if MC is bisecting, we know we have a midpoint. What letter or what point would be our midpoint? N. Yeah, so that's what we can say then. So we'll be able to say that N is a midpoint. I'm not going to write it down yet. We're just looking at our picture. So N is a midpoint. Okay, if N is a midpoint, what are we then going to be able to say? If we know that N is a midpoint, what are we going to be able to then say? Exactly, that DN is congruent to NL. If N is a midpoint, midpoints make congruent segments. So there's another set of congruent segments. Good. Now we've kind of used up our givens. We have 2 sets of congruent sides now. What else are we going to have? I see a bow tie shape. What's that mean for us? We are going to have vertical angles. And we can say that vertical angles are always what? Congruent, yeah. So we have vertical angles here, which means we're going to have 2 congruent angles. That right angle box doesn't really matter. I mean, it just tells you it's a right angle. You won't need to say it's a right angle, though, in this situation. But yeah, we're going to have vertical angles here. So we're going to have a set of congruent angles. So now take a look. We will be able to show these 2 triangles are congruent using which theorem? What do we think, guys? Take a look at the labeling. Yep, side, angle, side. All right, so let's fill that in now. So again, we were given a set of congruent sides, and then if you are given a vocab word, you should use it. We were given the vocab word segment bisector. If you look at your vocab sheet, there's a segment bisector is defined in there. If you go to it, it says a segment is a bisector if and only if it intersects a segment at its midpoint, or it's something along those lines, but you're going to have a midpoint. So what we said before was that N is the midpoint. So N is the midpoint of segment DL, because segment DL is the one that's being bisected. Sorry, my tablet's being glitchy in that one spot for some reason. Now it won't let me erase. There we go. Okay, that says DL, but it's just being weird right there. So that is the definition of a segment bisector. All right, then, so again, you had a midpoint, or you had a vocab word, so we used it. Now we have a new vocab word, midpoint. Remind us, what does a midpoint do? Not L though, because L told us before. So somebody else, I think it was L. It was L or Colin. I don't remember now. But somebody else, what's a midpoint going to do? Yes, it's going to split it into two congruent segments. So if we have a midpoint, then DL is going to get split into two congruent segments. So we're going to be able to say that DN is congruent to LN. So segment DN is congruent to segment LN. We were given a midpoint, so use that definition. That is definition of a midpoint. All right, then at that point, we have used up our given. Once you use up your given, look at your picture. Gannon told us we had what kind of angles? Somebody else besides Gannon. What kind of angles are we going to have if we have our bow tie shape? Vertical angles. And what do we know about vertical angles? They are always, always, always congruent. So we're going to have a set of congruent angles here. Something I would maybe do is label these as 1 and 2 in your picture, make your life a little easier. I'm going to call this top one angle 1 and this bottom one angle 2. So we are then going to say that angle 1 is congruent to angle 2. Anyone remember what the appropriate reason is for that? Yeah, very good. It is the vertical angle theorem. Good. And I don't mind if you say just like simply two vertical angles are congruent. That means the same thing. So now we're done. We were given a set of congruent sides. We found another set of congruent sides, and we had vertical angles. So we have a set of congruent angles. So somebody else besides, who have I heard from? I've heard from L, Colin, and Gannon. So someone besides those three, what theorem would we use here? What do we think? What should our last step be? What theorem did we use? We already said it. It's written in our picture. Come on, guys, try it out. You got a 1 out of 5 shot of getting it right, even if you're not even looking. Nobody at all thinks that they know. Yeah, good, Hannah. It's side, angle, side. We have 2 sets of congruent sides. We got a set of congruent angles. If you have these letters, guys, in this order, that's your only possibility. Use your picture. It says side, angle, side. So that's what our theorem is. Side, angle, side. All right. Do we see why it's side, angle, side? I'm worried that no one's talking except the same 3 people. This is not like necessarily super easy stuff, so I don't want to cold call people like just like calling you, because if you're confused, I don't want you to be embarrassed, but I'm just also not sure if we're not paying attention, because keep in mind, guys, I can't see you. So like, I don't know if it's like a confusion thing, like if I need to re-explain something, which is totally fine if I need to, but you need to tell me, because I'm talking to a computer. I don't know. So you got to communicate with me in some way, shape, or form. If I ask you a question and you don't know, then like tell me you don't know. If you think you know, take a shot at it. The worst thing that's going to happen is you're going to get it wrong, and then we can talk about why it's something else. It's how we learn. Okay, so I don't know. You gotta speak up, guys. So for number 3, it says we are given that D is the midpoint of segment AC, and we are given that segment BD is, what's this upside down T symbol mean? Yep, perpendicular. So BD is perpendicular to AC. So let's fill in our freebies. We have that D is the midpoint. Oh, I don't know why that's being like that. It's driving me nuts. D is the midpoint of segment AC, and segment BD is perpendicular to segment AC. That is given. We are going to prove that triangle ABC is congruent to triangle CBD. So then we just got to figure out which theorem works. Oh, thank you, ABD. Honestly, I saw the A and the B, and then I just assumed the last letter was C. ABD. Thank you. All right. All right, so let's take a look at what we are told. D is the midpoint. So this point right here is the midpoint of segment AC. So this is a great time to look at your vocab sheet. And can somebody tell me what a midpoint does? What does a midpoint do to a segment? Yep. Yep, it splits it into 2 congruent segments. If you have a midpoint, you are going to have 2 congruent segments. So segment AD is going to be congruent to CD. So we are going to then have a set of congruent sides from that. Good. Then our next thing in our given is that these 2 lines here, these ones here, are perpendicular. So somebody else, why might that be helpful? What do perpendicular lines give you? Right angles. Perpendicular lines give us right angles. Now, if this is a right angle and that's a right angle, aren't those both 90-degree angles then? So those would technically be congruent angles, and we could say that those 2 angles are congruent. Or maybe it's leading us in the direction of hypotenuse leg, right? One of those 2 things is maybe an option. So let's take a look. In order for this to be hypotenuse leg, though, don't we have to have a congruent hypotenuse? That's side AB and side CB. Is there anything there to indicate that those 2 sides are congruent? No, they're not marked as congruent. They're not a shared side, so we just don't know. So For these, yeah, we don't know that these are congruent, so it's not going to be hypotenuse leg. But what do we have? Aren't these two shapes connected? Someone besides Al and Colin, what do we have? What are we gonna? Yeah, good, Rosalind. Which side is the shared side? Yeah, this one that's kind of in the middle here, right? We would call this line BD. That's a shared side. So we can say that that is congruent to itself. So there's another set of sides. So if you take a look, we had our right angles as well. So we have two sets of sides and a set of angles. Which theorem are we going to be able to use here? Side angle side. We have a lot of side angle side going on. I think this next one. Not necessarily. I think that's just what happened in these pictures, just by coincidence, kind of. I think side angle side, it's one that it's easy to use some different vocab with, you know, because you're gonna have like congruent sides, so you can use midpoints, bisectors. So I mean, it is pretty versatile, I guess. I think on your homework though, it's pretty evenly mixed up. So here, so we have that we're going to do side angle side. So let's just go through and put what we have. Our first thing, if you have a vocab word, make sure you use it. We are given the vocab word midpoint. And L told us before, so someone else refresh our memory. If D is a midpoint, what are we going to have? If point D is a midpoint. Yeah. Okay. So Anna, you said a bisector. We won't have to worry about a bisector here. Since we have a midpoint, what are we going to know about these little segments here, Anna? They're congruent. So we can just go right from midpoint to saying they're congruent. If we add a bisector, then we got to do like the extra step. Bisector means midpoint. Midpoint means congruent segments. Here, we just have our midpoint. So we can automatically say that segment AD is congruent to segment CD. And that is the definition of a midpoint. That is the definition of a midpoint. So now we've used our one given. Look at the next one. We have some vocab again. This vocab is perpendicular lines. So somebody else that didn't tell me the last time, what do perpendicular lines make? Right angles. Okay, so if we have perpendicular lines, then we have right angles. So that's really the only place we can go. You got perpendicular lines, say you have right angles. Make your life easier here, and I would number these. I'm going to call this one angle 1 and that one angle 2. So I'm going to say that angle 1 and angle 2 are right angles. We knew that because we had perpendicular lines. So that is the definition of perpendicular lines. Now, it's not just quite enough to say they're right angles. We need congruent angles. But how many degrees are all right angles? 90. All right angles are 90 degrees, no matter what. So if all right angles are 90 degrees, they're all going to have the same measure. So technically, aren't all right angles just congruent? And that's actually a theorem we did at some point, but you can literally just say that. We can say that angle 1 is congruent to angle 2 because all right angles are congruent. I think, I forget what chapter we did it in, but it's technically like the right angle congruence theorem. all right angles are congruent. They're all 90 degrees. So we have now used up our given. We had a midpoint, so we used the definition of a midpoint. We had perpendicular lines, so we used the definition of perpendicular lines. Now we've run out of information here. Now we have to find information in our picture. Rosalind told us we had a special type of segment in here that's always congruent. Can someone else tell us what it is? When your two triangles are joined like that, what kind of side are we gonna have? We're gonna have a shared side. Okay, somebody else, which side here is the shared side? What do we call it? What's its name? Good, segment BD. So then somebody else, how do we talk about segment BD in our proof? You can look up at what we did in the previous one. It was in number 1, we had a shared side. Okay, so in number 1, we had a shared side. Take a look at that. How could you talk about your shared side here in number 3? I'm just going to wait until somebody tells me. No, I already know that you know, Colin. Sorry. I got to know that the rest of us are awake. So far, I only think that 4 of us have a pulse. Take a look at number 1. I'm not asking anybody to guess. I'm asking you to look at number 1. We said that segment AC is congruent to AC by the reflexive property. So now, just apply that to our new problem. How can we talk about our shared side in this problem? It's right here. It's segment BD. I got 35 minutes, so I'm not in a hurry. Nobody at all even kind of thinks that they know. Do we not know because we're confused, or I can't tell, guys. Do I need to re-explain it, or Danny? Yes. That's okay. The question is, we want to talk. We're at the point in our proof where we want to talk about our shared side, and I'm just asking everybody, how would we put that into our proof? We did it up here in number 1, where we said that AC is congruent to AC. So I just want somebody to tell me how we can then apply that here. If our we did the AD and the BC, here our shared side is BD. Yeah, so if on the last one we just said AC is congruent to AC, how do you think we could say that with this one? Like, what would we call this segment? Right, BD is congruent to BD. Does that kind of make sense, Danny? Because that's where the two endpoints are. Okay. So segment BD is congruent to segment BD. All right, and then what would be an appropriate reason? Somebody. It's the same thing we did up above. Yeah, thank you, Anna. It is the reflexive property. Good. And now we have, if you take a look at our picture, you should hopefully have the same labeling. We had 2 sides, and the included angle is congruent. So what do we use for our theorem here? Remember, we have our 5 possibilities that are up at the top. Is it side, angle, side, hypotenuse, leg, side, 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 angle, or angle, angle, side? Yep, good. It would be. It would be side, angle, side. We have two sides and a congruent angle. That's the only one that has this combination, right? The angle is where those two sides connect. So it's side, angle, side. Again, guys, if you're lost, you got to tell me. If you're lost, I'm not mad. I totally understand, but then you have to tell me so I can re-explain it. But if we just sit in silence, I'm just sitting in a room by myself staring at a computer and a bunch of little circles that have a picture in them. I don't know. So if you need something explained, tell me, because you're also probably not the only one, since we're all sitting here in silence besides like 5 of us. All right, this is the last one on here. So for this one, we are given that segment JK is parallel to segment LM, and segment MJ is parallel to KL. And we want to prove that triangle MJK is congruent to triangle KLM. So let's put in our freebies. We know that segment JK is parallel to segment LM. Segment MJ is parallel to segment KL. That is given. And we want to prove that triangle MJK is congruent to triangle KLM. All right, so this, we have parallel lines, which we talked about up here in number 1. When we had our parallel lines, remember, parallel lines give us congruent angles. So we're probably going to have to talk about some congruent angles here. So in this one, our given isn't already telling us that anything's congruent. We have to purely use our vocab, and we're given parallel lines. Remember, parallel lines, so parallel lines give us congruent angles. Parallel lines give us congruent angles. So here it says the top is parallel to the bottom and the left is parallel to the right. Who can remind us in a picture like this, and just in general in these proofs, what type of angle relationship happens? Is it alternate interior, alternate exterior, corresponding, or same side interior? Yep, we're going to have alternate interior angles. Remember, that is your Z shape. So if the top and bottom are parallel here, I can draw a Z shape connecting those like this. This means that these two angles here would be congruent. So we can put our congruent angles here. I'm gonna label these as 1 and 2. It's a lot easier. 1 and 2. Okay. So that is 1 and 2. So those will be congruent because those are our alternate interior angles. So there's a set of congruent angles. Now, if we could do that on the top and the bottom, if the left and right are congruent, won't we be able to do that somewhere else as well? It doesn't have to go from top to bottom. We can also put our Z shape going the other way. So with that, again, connect your parallel symbols. So connect your parallel symbol here, go across your diagonal, and then here. Oh, that turned blue. How lovely. Okay, so that means we're also going to have congruent angles in these corners. I'm going to label that with a 3 and a 4. Do we like putting the numbers for the angles? Does that make it easier to tell which ones I'm talking about? Okay. So, and if you need to, guys, kind of think about it like flip your picture around. Your Z shape would also work in that direction as well. So here we're going to have another set of congruent angles because 3 is congruent to 4. So Gannon, here's actually your one that doesn't end up being side angle side. We've used up our given. Take a look at how your picture is drawn. Is our picture giving us any additional information? Any other congruent sides or congruent angles based on how the picture is drawn? Yeah, we have a shared side again. What's the name of that shared side, El? MK. Yep. We have a shared side here, MK. So there is a set of congruent sides. So now take a look at our labeling. We had two sets of angles, and then the side that connects them. So which theorem do we think this would be? Remember, our options are side, angle, side, 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 angle, side, angle, angle, side, or hypotenuse leg. Which one do you think would work for this situation? Absolutely, Gannon. Good. It would be angle, side, angle. And this is why your labeling is so important, is because we can hopefully you're seeing this, we have an A, an S, and an A. Also, too, if you have two angles and one side, there's only two options. It's either angle, side, angle, or angle, angle, side. And that's why labeling like this is important, because you can see literally how they're positioned. You have an A, an S in the middle, and then another A. Good. So now let's put in our information. First, we had our congruent alternate interior angles here from the top to the bottom. So we are going to say that angle 1 is congruent to angle 2. And that is our alternate interior angle theorem. Then we had the left and the right were parallel, so we could also have our alternate interior angles going the other way. So we could also say angle 3 is congruent to angle 4. Now this is also the alternate interior angle theorem. Since these are both technically the same reason, would it have been okay to put these all in one step if we wanted to? Yeah, that would totally be fine. You know, when you're writing your own, I don't care. I think I just did it to space it out a little bit. But you could put that all in one if you want. Then we have our shared side. So let's try this again. We did it up in number 3. So remember, we had our shared side BD. So we said segment BD was congruent to BD by the reflexive property. We're going to apply that to this problem. How do you think we could talk about our shared side in our proof here? Because we got to try to apply it. It doesn't do you guys any good if I just write it all down each time. Let's see. Tyler, what's the name of our shared side? Like, what would I call this segment? The one that's kind of highlighted in blue going down the middle. Take a look at its two endpoints on either. Which two letters are there? Oh yeah, we're not there yet though. We're talking about, you are right, it would be angle, side angle, but we're looking like for this part, we're trying to, the A's and the S's are things I put there. Look at the little black letters, the ones that are there for labeling. What are the two endpoints on like that? Yeah, M and K. So we literally just call this segment MK. Do you see what I was asking now? Okay. So that segment is segment MK. Okay, so we know its name is MK. So now let's take a look at what we did up here. We said BD is congruent to BD. If this one's name is MK, Olivia, how do you think we could put that in our proof here? I saw that you went unmuted, but I didn't hear anything. So here we said BD is congruent to BD, because that was the name of the segment. It was segment BD. Here we have MK. So how could I show that? How could I show that MK is congruent to itself? You think you know how you could do that, Olivia? Yeah, I can hear you now. Uh-huh. Yeah. And would we put MK on just one side of the symbol or both sides? I'm sorry. Yeah, both sides. Yeah, we would say that segment MK, like this. Is this what you're saying, Olivia? I think your mic's being weird. I don't know, but MK is congruent to MK like this. I think this is what Olivia was saying. Okay. Let's see. Oh, Ethan, yes. Don't know if you meant to do that or if you were just like clicking the raise hand feature. I know you said your mic wasn't working. Okay. I got excited. I thought someone wanted to say something. So MK is congruent to MK. Abby, which property could I put here? You can look up at the previous proof if you need to. Yeah, this would be the reflexive property. Good. So that would be the reflexive property. And then I know we already said it, but let's make sure we know for sure. Trey, what would be our reason here? Would we like, which theorem would we use? Yep, angle, side, angle. Good. Okay. All right. Hopefully it's just that we don't want to talk and not that we are that confused. Let's